Hello everyone and welcome on today's video. My name is Wouter Peer and I'm the founder and main developer of GHEtool Cloud. And as you can see, our background has changed. And that's since we moved locations and we're still unpacking boxes. So I hope that once this background is 100% finished, I will be able to turn off the blur settings. So stay tuned for that. But today I want to talk to you about a new feature, small addition with perhaps a big impact for your project, and it's about hourly domestic hot water profiles. Now, to recall, domestic hot water, or DHW, plays an important role in the imbalance of your borefield. For example, in residential projects, we know that our domestic hot water demand can be in the same order of magnitude when you have a good insulated building as the heating demand. But the thing is that it typically does not play that big a role in the peak power, because the peak power in extraction is determined by the peak power of your heat pump, which is typically sized based on your heating demand. And that's why in the past we worked with hourly heating and cooling values, and we assumed a certain, or we let you enter as a user, a constant domestic hot water energy consumption per year. But that changes today, because there are some buildings, hotels, spas, swimming pools, etc., which rely very heavily on this domestic hot water profile, and it's actually the most dominant energy demand. And also they have very pronounced tap water profiles, with sometimes very high peak powers as well. And that's why we have embedded, or gave you the option now, in GHEtool version 2.4.1.3, which has been released today, to next to your heating and cooling demands, also upload an hourly domestic hot water tap profile. So we will show it in GHEtool later, but once you upload the file and there is an extra column for the domestic hot water, it will be recognized and you can also import that. Now let's talk about the compatibility with this new feature with all our existing methods. So with regards to the temperature profile calculation required tap, active and passive cooling combination, it all works. So there is no problem there. When we simulate a hybrid system, so if you have not watched the video on this topic, it's linked in the description below. But in GHEtool you have the option to simulate hybrid systems, where you say, well, above or below a certain threshold, we want a certain hybrid technology to be the primary source of heating and cooling. In this method, we assume that domestic hot water is always delivered by the ground source heat pump, since it will be the most efficient technology. So that's something important to keep in mind. Related to the optimization methods, we adapted the optimize for power and balance method to cope with this new hourly domestic hot water profiles. And the way we do this is that we say, well, our domestic hot water is preferably done by the ground source heat pump. So this means that whenever we have to limit our peak power on the ground, that we can choose whether we take away part of the domestic hot water or part of the heating. And the way this method is now set up is that we first take away part of the heating and keep the domestic hot water as long as possible on the ground source heat pump. In the future we will add more flexibility to this method, but at the moment that's the way how it is implemented. So let us jump now right into GHEtool Cloud, and I will show you where you can upload this domestic hot water hourly profile. So here we are in GHEtool Cloud, and let us now take a look at how you can work with this hourly domestic hot water profiles. So I suggest we work with the default values, but just for the borefield, I will enter a slightly bigger borefield based on the example I have prepared. So for thermal demands, you have here the option to download the profiles, and we updated these templates to also include an optional domestic hot water profile. Now, I have already created that for you, so let's go ahead and upload my profile. And since we now have 3 columns in our file, heating, cooling and domestic hot water, it will show up as, yes, there is domestic hot water, do you want to include it? Yes, I want, so I import it. And then I can go ahead and simulate it. And what you can see is, since we've embedded the hourly domestic hot water profile in our load, we cannot edit here because it's already embedded in our hourly load profile. We end up with a temperature profile, you're all familiar with that, but here you can see, especially on the right, that we have a very pronounced domestic hot water peak power. Now it looks like a constant bar, but it's actually, if you zoom in, a tap water profile. So let's zoom in even further. You see that in the evening at 7 p.m. we have our highest peak power of up to 30, almost 30 kilowatts, and then you have a shorter peak in the morning, which is typical for, let's say, a residential building. But what is important to see is that, if we zoom out again, that our peak power for domestic hot water of 30 kilowatts is most of the year actually the most pronounced peak power. It's the most significant. And if we take a look at the figure on the left, we also have embedded the domestic hot water profile in your load duration curve, where you see a similar profile to the heating demand, but with our lowest power having more full load hours, let's say. So this is a simulation we have when we do it with an hourly domestic hot water profile. We end up with a minimum average fluid temperature of 1.53 degrees Celsius. Now I want to compare this to the scenario you would had before. So let's go ahead, duplicate, and call this scenario 2 constant domestic hot water. So what I now will do is I will remove our profile and I will upload it again. And we will select that we do not want to embed any domestic hot water. So then we have the option to edit here as a yearly consumption, which is really easy, and it's 60 megawatt hours per year that we had. Now let us go ahead and simulate this again. And what you will see now is that, especially, let us wait a second, so here it is. If you take a look at our hourly load now, since we assumed the 60 megawatt hours, it's a constant load, it will be, 6.85 kilowatts for the whole year. So it's assumed to be constant, and also in our load duration curve, it's just one full 8,760 hours of your year that's assumed to be constant. But this, of course, differs quite a lot from our initial tap profile. Now, has this an influence on our design as well? Yes, it has, because here we are at, when we assume it to be constant, at 1.93 degrees Celsius, where before we had 1.53. So there is 0.4 degrees Celsius difference due to the fact that we now assume that our peak power for domestic hot water is just short of 7 instead of almost 30 kilowatts. And when you have buildings like hotels, spas, swimming pools, this effect will be even way more significant and pronounced. So that's how you work with domestic hot water profiles and temperature simulation. What I now just want to show you is, if I duplicate scenario 1 and let's call it scenario 3 optimize. Load, let's call it optimize power. To optimize power, we say, well, I want to optimize power. I'm just going to show the hourly results. Does not matter that much, but, and let's make it 4 boreholes of, let's say, 120 meters or so. So now what we're going to do is we are going to optimize our profile, including the domestic hot water. So if you have not watched our video on the methodologies on energy, power and balance optimization, our 3 options, it's linked in the description below. But basically what it will do now is it will make sure that our peak power on our borefield are chosen such that we stay within temperature limits. And when we're working with hourly domestic hot water profiles, the algorithm has to choose whether or not they are first going to limit the heating demand or they are first going to limit the domestic hot water demand. And by now, by default, we are always going to limit the heating demand first, because the domestic hot water profile or the domestic hot water generation with a ground source heat pump is typically the most efficient one. In a later update, we will add the option that you as a user can select which of these technologies is actually preferable. But before we do that, we still want to make some more changes to the methodologies to give you more flexibility. And this is the result we end up with. So you see, we optimized it so it stays exactly within these limits. And as you can see here, in our situation, around 63% of our heating demand can be delivered by the borefield, but 100% of the domestic hot water. And this is also visible on the low duration curve, where you can see that we have our red line, which is a building demand in heating, and we see here that the red hatched area is topped around, what is it, just short under 17, it's 14 kilowatts. But our domestic hot water, the full 30 kilowatts, can still be delivered by the borefield. So this clearly illustrates that our optimization algorithm, it shows us to first limit the heating, and then whenever this whole bar would have gone down, it will also limit the domestic hot water profile. So I hope this video was interesting for you, and I hope you will explore the options of adding your own tap water profiles to your hourly loads, so you have more influence, more nuance in your geothermal design. And I'm looking forward to seeing you in the next video. Take care. Bye.